Hello and welcome to this week's lecture. We're going to start off our exploration of healthcare finance with a foundational principle which you will never want to forget for the rest of your life. If you get anything out of this course, it is what you get in Module 1 is something that will carry with you in almost everything that you do in life, from deciding on what job you might take to deciding on what house you might buy, your college education, maybe your college education of loved ones or children, anything that will involve an exchange of value. This is the foundational principle. If you learn this, it will carry out through many, many different things in life. All right, so with that tremendous buildup that I've given it, we're going to be talking about the time value of money. So let's go in today's lecture. We're going to be working through some problems. I'm going to try something with you a little bit different in that I'm going to have you use a website rather than buy a financial calculator, but I will also talk about some financial calculators that you can get on your phone that you may want to have at the ready too. But we're going to try to get by with just the websites alone, and I think we should be able to do that for most of the problems involved in this course. All right, well, let's go ahead and start our discussion of the time value of money, and we're going to go ahead and remove my picture off of here. But basically, in this chapter, again, time value analysis, and it's looking really at um, that that monetary exchange of money that you might be getting in the future. You might be getting a stream of money in the future, and how do you make decisions based on that? So, for example, let's say it all goes kind of the classic one. Would you rather have Here's one. Would you rather have $1,000 a year from now or $900 today? How do you decide if those decisions are, equal? There's a way to do that, which is really, really cool. And then you can get more fancy with that. Is, let's say, for example, well, would you rather have $1,000 a year from now, or would you rather have payments every month of $75 um, for a full year? And which is equal to you, or how do you make that decision on what to choose? And again, time value analysis or time value of money allows us to make those decisions. And what's really cool about it is that it can be applied to so many things. As I was leading up to the build up on time value of money, that you can apply for purchasing a car, or the same principles that you'd use for purchasing an MRI machine. Um, Whether you decide to take a job that pays you a little bit more, over a X number of period of time versus the job that you have now, it can make those kind of decisions for you. So it is an extremely helpful tool that I have used all of my life since I was introduced to it as an undergrad, just as you are, on the time value of money. We've always known about it as kids. You put money in the savings account and it earns interest. But we'll talk a little bit more about that. So let's and we're going to be using some examples as we to kind of guide our discussion. But here, when you look at time value of money, the it's analysis is necessary because money has time value. And let me give you a thought experiment after this next bullet point. And a dollar in hand is worth more than a dollar to be received in the future. Well, why? Why is that? Well, if you read the textbook, the classic, the answer is, well, because um, that dollar can earn interest. If if a dollar being equal, a dollar in my hand right now versus a dollar given to me a year from now, well, if I have the dollar in my hand and I put it in the savings account, and savings, by the way, is the lowest I've ever seen in my lifetime. The interest rates are dismal, but let's just dream that savings accounts are paying 3%. Um, I could put that dollar in a savings account earning 3%, and I would have more money at the end of one year than the other offer you gave me, which is paying me a dollar in the future. So it's worth more to me in hand. Now, here's the thought experiment. So you have interest. That's kind of the whole thing that drives this, is something called an interest rate. But why is there an interest rate? Why is money given that? Well, in banking, your money is you put it into a checking account, a savings account. That money earns, again, I'll be generous, 3%. The bank will then turn around and loan that money out to other individuals, say earning 6%. And the bank will basically live off of the spread between the 3% and the 6%. They'll make all of their money to survive by handling that exchange for people. But it still goes back to why are some people willing to get loans now? Give me a loan. I need $1,000 right now. Give it to me. Um, and I will pay that 6% interest rate. Why are people willing to do that? And I think that is an interesting question is why is there, that money is given that sort of interest rate value inherent in time. And what I think is, and I've never really read it specifically, but I think it has to do with the fact that we have limited lifespans. So if we want to get things done in life, let's say if I live forever, right? Whether I get $1,000 today or $1,000 100 years from now wouldn't make a difference. Time would be irrelevant. But because time is a commodity, and that commodity is limited, because we are mortal, we have these limited lifespans, that whenever you have scarcity, it adds a value to the time itself, and that is expressed through an interest rate. And there's other things that affect interest rate as well. The risk of certain things too. But I think that's why. I mean, it's more of a thought experiment. Why does that even exist anyway? And I think it really has to do with you're only going to live so long, and you got to prioritize those things that you want to do, and sometimes you're willing to pay a little bit extra for that, and that can be through interest rate. Okay, so enough on that. Well, and then as we go through kind of our bullet points, because of time value, the values of future dollars must be adjusted before they can be compared to current dollars. That's what I was talking about. There is a way to do this comparison. And that is what time value of money analysis does. We do something called discounting. It's not like necessarily like I'm going to get a discount at Target or Kohl's is running a great discount today. It's similar in that there's a value, but it just really means the value is adjusted, brought back, discounted back to a point in time. So you then can make a comparison between two different options. Okay, let's look at some our next slide here, and again, this will help with examples. One of the things you'll see often in time value of money questions or presentations is this timeline. So kind of know, and the timeline really does help. I mean, if you're trying to break down a complicated problem, especially a problem that has what we call multiple cash flows, where you're receiving money, you're going to get X amount in year one, X amount in year three, and X amount in year seven. You can build these little timelines and kind of help you um, not get lost as you're running through the problem. So I would recommend if you feel like you don't know where to start, draw a line and start that way. And there's some conventions that we use here, and we talk about the conventions. Times zero is always the starting point, and the little hash marks will indicate the end of a period. So that's the timelines there. So again, a nice little helpful tool. I do use them frequently if I'm trying to bust down a time value of money problem. All right, so here comes. Let's put this in an example. So, and we're going to use some terms here. As we're rolling out these various examples. This is going to be a future value question. So you'll see the word FV in there. So there's one for you. Future value is FV. That'll also tie into any kind of financial calculator that you have. It'll have this button on there that says FV. Well, what does it mean? Flavor? No, it means future value. So, okay, so what is the future value after 3 years of a lump sum invested at 10%? You'll hear the word lump sum, but that just means it's not going to be $100 now and $75 later. It's just bloop, one lump sum invested at 10%. Wow, that's a nice interest rate. And that goes back sort of to your classic savings account question, where you put in $100 into a savings account at 10%, dream on, not going to happen with their savings account, but at 10% for 3 years, how much money would you have? Now, there's another term, we'll go through these other terms here, compounding. All right, you've always heard about, I'm sure by now you've heard about the mythical powers of compounding. And what that means is that the interest is earned after year one. Obviously, you're going to have a little bit more money, right? You're earning 10%. Then in year two, that interest is going to earn interest. And I'm going to throw another word at you. The principal is going to be earning interest. The principal is that initial lump sum dollar amount. So when you hear that mentioned, that's kind of like your starting amount, the original times zero amount is referred to as principal. So you've got that compounding effect. And then also another word you'll hear about interest, and this can get kind of complicated. But the good news is that you can simplify it. I mean, if you need absolute precision, then it makes a difference. But right now, as far as this illustration goes, we're going to use the simple method, which is how is interest compounded? And there's multiple ways interest is compounded. You could have it compounded annually. You could have it compounded semi-annually, it could be and anything in between in there, monthly, and there's even something called continuous. So, it basically you can get good estimates by just using annual, and makes the math a little bit easier. But so I guess don't get too worked up on that. But it is important to know the difference that there are different types of compounding calculations that can be applied. And though I'm saying don't worry about the small details, if you're doing a deal for $1 million and you are using an interest rate, and again, whatever side of the deal that you're on, and it could make a huge amount of money difference, you know, 70, $80,000 is a big difference. I mean, to when making a decision for an organization or you individually on how interest is compounded. It's interesting too that when you're looking at investments, that can make a difference too because they're not one that will pay continuous. Interest that's compounded continuously is actually going to be better for you than annual compounding. So that could be a slight difference in there. But all right, well, right now we're going to assume annual, which is the easiest type of compounding method out there. All right, so we know the parameters of our problem, and now we're going to try to set this up with some formulas. Now, don't let this, blow you away too much here. But basically, what you're going to have here, and there's going to be a couple methods we'll talk about solving these problems. But again, we're going to solve for the first period. So the future value here in future value 1 in after period 1 is we're going to take that present value plus the interest rate, which we'll just call INT, and will equal the present value plus uh, open parentheses, present value times the interest rate. All right, well, let's plug this into the formula and see what it looks like. So we've got our formula down here, bringing this down. We're going to plug in our present value. We know what that is in this case, right? So it is $100. We know what our interest rate is. That is 10%. But we got this formula. It just tells us what to do. 1 plus the interest rate, I. What is that? Well, when interest rates are expressed as a decimal point, so in this case, it's 1.10. Multiply it, and you get your answer that you're going to have at the end of that first period is you're going to have that $110. So if we were to go back to our little timeline, we could put in 110 at the end of period 1. We got some more periods to go, so we got to do period 2. And with here, same formula, but now we have to take into account that we have our interest earning interest. So that's the tricky part. And now we're going to bring in something called an exponent. So this is where it's where most of you will probably freak out because of the math involved. Again, I'm going to show you the calculator method, and I think you're gonna really like that. Well, I'm going to jump right down here to the bottom here. Of course, you got the formula right here. It's also listed in the textbook. But again, we've got our initial principal amount right here, or that lump sum, times 1.10. Again, the 1 plus the interest rate. And we have an exponent of 2. So the order of operations, if you remember how that works, you're going to calculate this first, and then you're going to multiply that times 100. Once you get that, you're going to get $121. So now you know what it would be at the end of year 2. Let's go on. I think we got one more year to go. With year 3, I think you probably got the gist of it now. Just jumping down, getting to our formula here, with the principal amount times the 1 plus the interest rate to with the exponent 3, because we're using 3 periods. Whatever a period, that could be arbitrary too, but mostly years. 3 years, 3 periods, annual compounding. We're going to put a 3 in there, and that is going to have 100. So the answer, I guess, to the question was, we now know that at the end of 3 years, at 10%, you're going to have $133.10. Here is the power of the compounding. And let me go back to. All right, so if you took this first one, you go, well, yeah, I make $10 a year. It's 10%. I make $10 a year, right? So at the end of 3 years, I should have $130, right? Well, remember, it's the compounding effect. So instead of having the $130, you actually have that $133.10. So I guess when you look at the effect of the compounding, it's $3.10, because the interest then begins to earn interest itself. So in general, there is the formula that you will use, that if you wanted to do it kind of by longhand. Okay, so there is the longhand method right there. Future value is going to equal present value times 1 plus the interest rate, whatever that is. Remember, convert it over to a decimal point. And n, another number that we use here, a convention, n is the number of periods in whatever the problem may be. Okay, now let's go on and talk about the 3 methods. Now, what you just saw there, we solved the future value equation using a calculator. So and you can be non-financial. We actually plugged and chugged with the exponent value, through each one of those kind of scenarios. Then another option, the most popular, is using a financial calculator. Again, we're going to try to use a website here, and then you can also use Excel. I'm going to try for this class, I'm going to try to avoid using Excel. That would be it is an option out there, but I think it would add a layer of difficulty for folks right now who may not be familiar with Excel. So, but if you are, I mean, great, you can go ahead and use that. You can actually drop in pre-made formulas that are already in Excel. The big thing is go away with knowing that Excel can do this. So if you are ever challenged in your work and you are told to build a spreadsheet, you could, where you needed to do some time value analysis in there. You can do this. Wonderful tutorials all over Google, all over YouTube on how to do that. If you're ever in your career ever needed that challenge, so it is there. All right, but again, we're going to try to stick with the calculator, the financial calculator, or the simple non-financial calculator methods as much as we can for this course. So let's go back. We already did the non-financial calculator solution where you can calculate each one of those years. You don't have to do each year, but that was just an illustration of what it would be if you were looking at your account statements. If you open that account statement at year 1, you'd have $110. At year 2, you'd have $121. And at year 3, you would open up your final account statement. It would be $133.10. Okay, so more interestingly is the financial calculator solution. So this is where you're going to be doing some inputs, and I'm going to bring up a website here in just a moment. So remember, we talked about the N is the periods, the I is the interest rate. We'll have present value in here, and I'll talk about that negative in just a second. You may have payments involved or may not. So in this particular situation, we don't, but we want to find this future value. So let's um, let's go ahead and bring up a calculator here. Let's bring up that calculator, and I'm going to use one right now. We'll try this and see if it works. Um, from arachnoid.com. I don't know what this guy does, but apparently he has a lot of time on his hands and he built himself a bunch of calculators and other stuff on his website. But he has a nice little financial calculator on there that we're going to try to use. I'll introduce you to another one that's at calculators.com. And That's got some cool graphing kind of functions in there too that are kind of nice. But we'll bounce back between the two. But right now we'll have this one, the arachnoid.com, slash finance. So use that website and check out that his calculator. Again, it's so far I've been playing with it and it appears to be pretty accurate. All right, so let's go ahead and close this out and don't save. Okay, great. All right, now and pull up the website here. Sorry, guys. There we go. Okay, so here I'm at arachnoid.com in the financial calculator, and he uses the terms that are very similar as well. So as you can see here, let's just start from scratch here, and let me clear it so you guys we can build this together. So there's some sample values that are in there. All right, so let's just simply fill in the information and see where the calculator takes us. So we have a present value that we know, and that's 100. Now, for many financial calculators, including this website, it uses the negative convention. So what that means is whenever you're entering a present value, you have to enter it with a negative. If you forgot to do that, your answer would come up in a negative, and then you'd realize, oh yeah, I forgot that negative. So I think you would catch yourself anyway if you saw that. And the answer would still be correct. I mean, the number would be correct. It would just be a negative, and I think you'd know it wouldn't make any sense if it was a negative. So if you forget, don't worry. You should still be able to remember that you forgot to put a negative in there. Or think of it this way too. I mean, I'm trying to think of I guess a good way. It's $100 that you're putting into something, maybe a savings account. So you're getting rid of it. Think of that. Maybe that helps. That you have to put in a negative. Future value, huh? That we don't know. So I'll skip that. Number of periods. Well, that we do know, right? And that was 3. So we'll do that. Payment amount. Is there any payment amount in this question? No. We'll put that to 0. And interest rate. In this case, you don't worry about putting a decimal point. You just put the real interest rate, I guess, as a whole number in there. And in that case, I believe we were at 10%. Okay. Also, I'm going to throw another thing at you. Remember I said there's interest rate that's compounded continuous or annual or even semi-annual. You can also have how that payment is handled, whether it's at the beginning of the period or the end of the period for your interest. Most conventions, most standards are at the end. So we're going to leave that where it's at. But just make sure if you're messing around with any financial calculator and you're wondering beginning or end, just make sure it's set at end unless told otherwise. All right. And what's nice about his little calculator that he built is computation incomplete. Compute a result or enter more values. So it knows you're not done until you hit a button. And the button we want to hit in this case is future value. So we're going to go ahead and hit that and see what happens. Boom. There we go. $133.10 using this little financial calculator. Again, there is a really powerful tool for you right there where you can now calculate the value of the lump sum in the future. So it's almost like you can tell the future. All right, we will continue with different lectures on different ways to play with this whole value of time value analysis. But what you just learned right now is how to take, again, a lump sum and go out as many years as you want, 100 or more, and figure out what that value would be in the future.